In this video, we will see I2C communication protocol. First, we will see what is I2C. I2C can be expanded as integrated circuit. It is one of the serial communication protocol. It is a bidirectional data transfer protocol and it is a half duplex. Half duplex means that the data can be transferred from one medium to the other medium with a single line. The data transfer can happen from 1 to 2 or 2 to 1. But the thing is, at a single time, only one can transmit the data, so other will receive the data. So that this kind of communication is known as a half-duplex communication. So I2C has only one data line. That's why I2C also a half-duplex communication protocol. I2C is a synchronous communication protocol. This is synchronized with a clock signal. So clock is provided to synchronize two devices in communication time. Clock is controlled when data line is changed. Whenever the data needs to be changed, the clock is controlled. This is a simple prototype of I2C communication. Here, I2C communication have n number of masters and n number of slaves. This is a basic I2C prototype. It has only one master and n number of slaves. The master can be a microcontroller and a slave can be a LCD display or EEPROM or any other microcontroller. So from master, two lines are taken out, that is data line and clock line, SDA, SCL. So this SDA and SCL is connected to the n number of slaves like this, as shown here. So from master, only one SDA line and only one SCL line is taken out, so that the number of wires gets reduced when we compare it to SPI communication, which increases the number of lines as the slaves increases. This is one of the advantage of I2C protocol. We will move further. Speed of a I2C communication protocol can be split to three types, that is low, which is under 100 kbps, and a fast 400 kbps, and high speed, which is 3.4 Mbps. This 3.4 Mbps communication is available only in I2C version 2.0. I2C is a two-wire communication. It has SDA and SCL. When voltage is high, it is considered as 1. When voltage is low, it is considered as 0. Here we can see how the SDA and SCL lines are connected with a master and two slaves. When SCL is 1, data is a valid data. When SCL is 0, which means data changes. A basic I2C protocol is a master-slave protocol, that is a single master and single slave. Master controls the clock. Always, slave device may hold the clock low to prevent data transfer. no data transfer is present when clock is low. Slave device pull the clock low when the data transfer should not occur. So this is the one way of preventing data transfer by the slave. It is a kind of wired and connection, which means and connection. Wired and connection. It is a wired and connection. We will see why I am telling this is a wired and connection later. By default, I2C lines are open drain or open collector. So adding pull-up is necessary so that it will have only two states, that is floating high and drive low. Default, the pull-up state is high. That means by default I2C lines will have high state. So whenever the device needs to be pulled low, it will go to low. That time data transfer may happen. That is the need for adding the pull-up resistors. This is the packet format of I2C protocol. I2C protocol has start bit and address, which is 7 to 10 bits, and read write, that is master to read from slave or master writes to the slave. Which kind of communication needs to be happen, that is specified in this bit. After that, ACK, the receiver sends the ACK, so that is the ACK bit, and 8-bit data from master or from slave, that is decided from this end. And again ACK, and again another data, and again ACK, and it goes on as long as the stop bit received. This is the simple explanation of I2C packet. We will see all this. This is the start condition of I2C protocol. Here SDA is high and it changes to low. Here SCL is high. So the start condition is SDA changes from high to low. Here SDA is changing high to low when SCL is high. This is the start condition of I2C. The stop condition of I2C is shown here. Here the data line changes from high to low. Here the data line changes from high to low when the SCL is high. This is the stop condition of I2C communication. Repeated start. In this case, repeated start condition is generated instead of stop frame. Data transfer. It is a byte-oriented data transfer. So 8-bit of data is transmitted. ACK is transmitted by recipient of the data. It is MSB first and LSB next kind of data transfer. It may vary based on the slave. For that, we need to understand the slave's data sheet. In all kind of communication, first byte from the master is always a address. The first byte is transmitted by master and addressed slave is the recipient. Next byte, that is next byte, is based on the last bit of RW, that is read or write. In the first packet, 7 bit will be the address and 1 bit will be the read or write. So when read write bit is 0, master will be the writer, and when read write bit is 1, master will be the receiver. And the ninth pulse is acknowledgement bit. So acknowledgement bit will look like this. Acknowledgement means data line to low. Here we can see this is the ACK, and this is not acknowledgement or negative acknowledgement. So the SDA line is pulled by the slave to low to give the acknowledgement to the master, and that time master gives the pulse. Master gives the pulse with respect to the accepted speed so that it generates the clock. That time SDA need to be pulled low by the slave to give the acknowledgement. We will see the full I2C data transfer in this image. Here we can see the start condition and the data lines and ACK and stop. So SDA high, SCL high, this is the idle time, and SDA high to low when SCL high, that is the start condition. While SCL is high, this bit detected. While SCS is low, data is allowed to change from 0 to 1 or 1 to 0. This ACK bit is sent by the receiver by pulling it low when the clock is high, and this is the stop bit, that is STA low to high and SCL is high, that is the stop condition. Here the full image of I2C data transfer is given. First, the clock is start generating and the master gives the slave address, and that particular slave will listen and start listening to the master, and it becomes the receiver. Here the address is 7 bit, and the next bit is read or write, and then ACK is given by the slave by pulling the data line low when the clock pulse is generated. So based on this read or write, the data transfer is happened by sending or receiving the data, and again the ACK is given, and it continues, and the next data transfer happens, and again a ACK, and the next data transfer ACK by slave, and it goes on as long as the stop condition is received. This is how the data transfer happens from a single master to multiple slaves. I2C is a multi-master communication. So, bus arbitration is required. When two devices tries to drive STA to different value, it is necessary to be sure that is not interfering with another message. If a device is trying to send a logic and but hears the logic 0, that is trying to send a logic 1 but hears 0, it immediately stops transmission and gives the other sender priority. Synchronization is needed in clock in case of I2C multi-master, that is arbitration. We will look into the advantages and disadvantages of I2C communication. The advantage of I2C communication is it is good for onboard devices. That is, when the data transfer needs to be happen from one device to other and which requires less distance. So in that conditions, this kind of I2C communication is more important and easy to implement. Easy to link multiple devices because of addressing scheme. Cost and complexity do not scale up with the sum of, that is, number of devices. And the disadvantage of I2C communication protocol is the complexity of supporting software components can be higher than that of the scheme, that is SPA, which does not have address. This is one of the disadvantages of I2C communication. When we try to implement the I2C, we may face many problems. So, uh, they don't have any other communication options earlier like CAN. So that's why many of the old communication have I2C. Nowadays, the CAN is introduced and which prevents some of the disadvantages of this SPI and I2C. This is the end of I2C communication protocol. Post your doubts in the comments and don't forget to like if you like this video, and surely you need to subscribe. Thanks for watching. Keep subscribed for more upcoming videos. Thank you.